In an age without modern machinery, steel beams, or computer simulations, medieval builders managed to create bridges that have stood for hundreds, even over 1,000 years. These were not just crossings over rivers, they were feats of engineering brilliance, spiritual symbols, and lifelines for empires. But how exactly did they build structures so resilient with tools so primitive? The answer lies in a combination of genius design, deep understanding of nature, and craftsmanship that modern builders still admire today. Before a single stone was laid or an arch was envisioned, medieval bridge builders turned their attention to what lay beneath: the foundation. For them, the real strength of a bridge wasn't found in its towering arches or heavy stone blocks, but in the hidden earth below. Without a stable foundation, even the most majestic structure would crumble. That's why medieval engineers, despite their limited tools, went to extraordinary lengths to ensure the ground could support what they were about to create. The first step was understanding the landscape. Builders didn't just choose any location, they scouted riverbanks and valleys, studying the soil, the slope, and most importantly, the behavior of the water. They looked for natural choke points where a bridge could be shorter and where the current was more predictable. Bedrock was the ideal base, as it offered immovable stability. But when bedrock wasn't available, they had to improvise with ingenuity and brute force. One of their most important methods was the use of wooden piles, massive timbers driven vertically into the earth until they reached a firm layer. These piles acted like underground stilts, supporting the stone above and distributing its weight across a larger surface area. In particularly marshy or soft ground, entire forests were sacrificed to create these substructures. Oak was a common choice, not only for its strength, but also because it resisted decay when submerged in oxygen-poor, wet environments. Paradoxically, water helped preserve the wood. Some of these timbers are still intact under bridges centuries later. To drive these piles into the ground, builders used primitive but effective pile drivers, large wooden frames with weighted hammers that were hoisted by ropes and dropped repeatedly onto the pile's head. It was slow, grueling work, often done by teams of laborers who worked in rhythm, raising and releasing the hammer again and again, sometimes for days on a single pile. In wider or deeper rivers, the builders employed cofferdams, ingenious temporary enclosures made of interlocking wooden planks sealed with clay or animal fat. These structures allowed workers to pump out water and create a dry working area in the middle of a riverbed. It was risky and labor-intensive. Cofferdams could collapse under pressure or flood suddenly, endangering the workers inside. Still, these makeshift underwater chambers gave builders the opportunity to lay stone foundations directly onto the riverbed with precision and care. Once a dry workspace was established, workers began constructing the foundation piers, massive stone blocks laid one by one, often without mortar, relying solely on the sheer weight and expert shaping of the stones to lock them in place. The accuracy of this early phase was critical. If the base was even slightly off, the entire structure above could become misaligned, putting stress on the arch and accelerating wear. They also had to consider the force of the river itself. Medieval rivers weren't gentle streams, they were often unpredictable and dangerous. Builders accounted for this by orienting piers in such a way that they split the current rather than fought against it. Many bridges included pointed cutwaters at the base of each pier, triangular extensions that broke up the flow of water, reducing pressure on the structure and preventing sediment buildup that could weaken the foundation over time. The sheer amount of labor, coordination, and foresight required at this stage is staggering. Keep in mind, this was all done without electricity, hydraulic equipment, or computer models. It was the human eye, a deep respect for the environment, and generations of passed-down wisdom that allowed them to create a base strong enough to hold up not just a bridge, but the weight of armies, merchants, kings, and time itself. Their work beneath the surface, unseen by most, became the silent guardian of everything that followed above. The defining feature of medieval bridge construction, the stone arch, was more than just an architectural choice. It was a revelation. While earlier civilizations like the Romans had pioneered the technique, medieval builders inherited, refined, and mastered the use of the arch, turning it into a symbol of both beauty and resilience. The arch wasn't just practical, it was a testament to a deep understanding of physics, geometry, and the natural forces that act upon a structure. At the heart of the arch's brilliance is its shape. A flat bridge places all its weight directly downward, requiring strong materials and constant support underneath. But an arch distributes the weight outward and down, channeling the force into the abutments on either end and the piers in the middle. This means the heavier the load, the tighter the arch presses into itself, making it stronger. The entire structure works as a single cohesive unit, each stone depending on the next. If built correctly, it creates a self-supporting system so stable that many bridges remain standing today with little more than their original materials holding them together. To create an arch, medieval builders used a methodical, almost ceremonial process. The first step was crafting a wooden frame called a centering, an exact replica of the arch's underside. This wooden skeleton, often built from dozens of pieces, had to be precise to the millimeter. If the centering was off, even slightly, the arch would be unstable. These temporary wooden structures were placed between piers, resting on scaffolding or the riverbed, and had to be strong enough to hold the weight of the stones as they were laid. The stones used to build the arch were called voussoirs, wedge-shaped blocks carefully carved to fit the curvature of the arch. Each voussoir had a specific place in the structure, and they were laid symmetrically on both sides, working from the bottom upward. As they rose, the shape of the arch began to emerge, but it wasn't stable yet. The critical moment came with the placement of the keystone, the central voussoir at the top of the arch. The keystone locked all the other stones into place, allowing the forces to push against each other and downward into the piers. The moment the keystone was inserted and the centering was removed was both thrilling and terrifying. If the calculations were correct, the arch held firm, and from that point forward, the stones would need no support. If the measurements were even slightly off, the entire arch could collapse under its own weight. To reduce this risk, master builders often performed smaller-scale tests using wood or clay models, or built miniature arches nearby to test their angles and techniques. But not all arches were the same. Builders tailored their designs to suit different conditions. Some bridges featured semicircular arches, while others used pointed or Gothic arches, which rose more steeply and distributed weight more vertically, ideal for narrow crossings or areas with stronger river currents. The style also allowed for taller structures with fewer supports in the water, reducing resistance to flow and the buildup of debris. Multiple arches were often used in a single bridge, connected by massive piers that held them together like a chain. This modular design allowed the bridge to span great distances while remaining flexible and adaptive. If one section was damaged, say by flooding or war, the entire bridge didn't necessarily fail. Builders designed for both strength and resilience, knowing that time and nature were relentless opponents. The durability of the arch also lay in the quality of craftsmanship. Medieval masons didn't rely on mortar to bind their arches. Instead, they meticulously shaped each stone to fit perfectly, like puzzle pieces. The precision was astonishing, so much so that some arches, when viewed today, show barely a crack between the stones. This dry stone technique, although slow and laborious, created a flexibility in the bridge that allowed it to shift slightly over time without breaking, a crucial feature in areas prone to earthquakes, floods, or heavy traffic. More than just a structural necessity, the arch became a spiritual and cultural symbol in medieval Europe. It represented harmony, divine geometry, and the human ability to overcome nature through understanding rather than force. In religious thought, the arch was seen as a metaphor for the heavens, stable, eternal, and perfectly balanced. Monasteries, cathedrals, and even the bridges that connected them were infused with this sense of sacred design. It wasn't just engineering, it was art guided by meaning. The arch also influenced the economic and social dynamics of medieval life. A strong, enduring bridge enabled trade to flourish, armies to march efficiently, and cities to connect in ways that shaped the political landscape of Europe. And all of this rested on the humble yet profound brilliance of the arch, a simple curve that turned stone into something nearly eternal. Behind every enduring medieval bridge was not just a brilliant design, but a community of craftsmen, laborers, and visionaries working in harmony. At the center of it all stood the master builder, a figure both revered and feared, combining the roles of architect, engineer, artist, and project manager. Though they lacked formal engineering degrees or digital tools, these builders possessed an almost mystical understanding of materials, physics, and aesthetics, acquired through years of apprenticeship and hands-on experience. Their vision transformed heaps of stone and timber into masterpieces that would defy time. The organization of a medieval construction site was a feat in itself. Dozens, sometimes hundreds of workers were involved in a single bridge project. The team included stonemasons, carpenters, blacksmiths, quarrymen, rope makers, laborers, and watermen. Each played a specialized role, contributing to the larger whole. While the master builder directed the project, the individual skill and dedication of each tradesperson were essential to the success of the build. Stonemasons were among the most highly respected. Their task was to cut and shape each block of stone with incredible precision, often on site, using chisels, mallets, and tracing templates. These craftsmen understood the properties of different types of stone: limestone, granite, sandstone, and selected materials based on their durability, weight, and weather resistance. A good mason could judge the integrity of a stone by its sound when struck or by the feel beneath his hands. Their motto might well have been, "Measure twice, cut once, but cut with perfection." Carpenters, meanwhile, were responsible for building the temporary wooden frameworks essential to bridge construction. This included the centering for arches, scaffolding to access higher points, and support structures to hold stones in place during assembly. These temporary wooden constructs had to be strong enough to carry tons of stone, but precise enough to shape the geometry of the final structure. A mistake in carpentry could be just as disastrous as a flaw in masonry. Blacksmiths played a less visible but equally crucial role. They crafted the iron tools used by every other worker on site: chisels, hammers, nails, clamps, and lifting devices. They also helped construct the winches and pulleys that moved heavy stones into place. Some advanced sites even featured rudimentary cranes, powered by human or animal treadmills, to hoist massive blocks up into the air. Without the blacksmiths, the tools of construction simply didn't exist. Perhaps the most underrated members of the team were the common laborers. These men hauled stone, mixed mortar, carried timber, and performed the punishing physical labor that made everything else possible. Their work was dirty, dangerous, and exhausting, often done in extreme weather, knee-deep in mud or waist-deep in river water. Injuries were common, pay was meager, yet without them, no bridge would ever rise from the ground. Despite the lack of blueprints or computers, the master builder maintained control through rigorous planning and an intimate knowledge of geometry. Plans were drawn not on paper, but in sand, on wooden tablets, or directly onto stone slabs with charcoal or chalk. These sketches were less like modern architectural diagrams and more like visual reminders for someone who already carried the entire structure in their head. Geometry was the language of the medieval builder. Using tools like the compass, square, and plumb line, they laid out perfect angles, curves, and alignments. The compass helped mark arcs and circles. The square ensured right angles. The plumb line, a simple string with a weight on the end, verified vertical alignment, a vital tool when constructing piers or aligning arches. These tools were not merely practical. They had symbolic and almost sacred importance. Geometry was considered a divine science, reflecting the order of the universe, and a good builder was someone who could manifest that order in stone. Communication on the site was done through direct instruction, hand gestures, and a shared understanding of the craft. Written instructions were rare. Most knowledge was passed orally, from master to apprentice. And because building projects could take years, sometimes even decades, Many of the workers would spend large portions of their lives on a single bridge, slowly watching it rise stone by stone. The process of lifting, placing, and securing the massive stones that made up a medieval bridge required both coordination and ingenuity. Builders used sledges, rollers, ropes, and block and tackle systems to move the stones from quarries to the site, then into place. Winches and cranes operated by human muscle or animal power were carefully positioned and stabilized. Everything had to be synchronized. The placement of a keystone or the setting of a pier block often involved a dozen men moving together in rhythm, guided by the steady hand and sharp eye of the master. Despite the grueling nature of the work, there was a profound sense of pride and purpose on these construction sites. Many bridges were built for religious reasons, pilgrimage routes, connections between monasteries, or donations from nobles seeking salvation through works of charity. Others were commissioned by towns to improve trade and transportation. In either case, workers knew they were building something that would outlive them. The knowledge that their labors would carry travelers, traders, and kings across rivers for centuries gave their efforts a deeper meaning. In the end, it was the collaboration of skilled hands, disciplined minds, and visionary leadership that made these bridges possible. Every chisel mark, every wooden brace, every precisely carved block was the result of collective human effort, a harmony between intellect, strength, and spirit. These medieval builders, with their rudimentary tools and boundless ambition, didn't just construct bridges, they built legacies. While the strength of a medieval bridge lay in its foundations and arches, its true genius often revealed itself in how it stood against the forces of nature. Medieval builders understood something modern engineers sometimes forget. You don't conquer nature. You cooperate with it. Every stone placed, every pier designed, was an intentional conversation with wind, water, temperature, and time. Medieval bridges weren't just built to stand, they were built to survive. Water was the most persistent threat. It could undermine piers, erode banks, and rise suddenly with floods, carrying debris and ice that battered even the strongest stone. Builders didn't just account for these forces, they anticipated them. One of their most effective strategies was the use of pointed cutwaters, sharp triangular extensions built into the upstream and sometimes downstream sides of the bridge piers. These cutwaters did exactly what their name suggests. They sliced through flowing water, reducing the pressure on the structure and guiding the current smoothly around it. Without them, the force of the river would strike each pier like a hammer, gradually eroding the stone or even tipping the entire structure. But cutwaters did more than just deflect water. They also prevented the accumulation of debris. Trees, logs, and sediment would often float downriver during storms or floods. Without a way to divert these materials, they would pile up against the piers, increasing pressure and acting as a dam that could redirect water in destructive ways. By splitting the current and clearing a path for debris, cutwaters reduced both the physical and hydraulic stress on the bridge. Elevation was another form of adaptation. Medieval bridges were rarely flat. Instead, they were often built with a high central arch, or humpback shape. This allowed the bridge to rise above typical flood levels, reducing the risk of being submerged during seasonal surges. The shape also had a practical function in dispersing weight. A high central point meant that wagons, animals, and pedestrians naturally slowed down at the steep incline, reducing the overall strain on the bridge's central span. Piers were also spaced carefully. The wider the river, the fewer the number of piers in the water. Why? Because every pier introduced another obstacle to the flow. Too many piers increased turbulence, erosion, and the risk of structural failure. By minimizing the number of supports in the river and maximizing the strength of each individual span, builders created bridges that were not only more efficient, but also more durable. Builders also factored in the thermal expansion and contraction of stone. They understood that materials expanded in heat and contracted in cold. And while they may not have had scientific formulas to explain it, they observed the consequences over generations. Joints were sometimes left slightly flexible, and expansion gaps were included between certain blocks, allowing the structure to breathe with the seasons. This subtle give and take in the design meant that bridges didn't crack under the pressure of environmental changes. They adapted. Weathering was another enemy of stone, especially in regions prone to freezing and thawing. Water that seeped into cracks would freeze in winter, expand, and split the stone apart, a process known as frost wedging. To prevent this, medieval builders often used carefully selected stone types less prone to cracking. They also included drainage features, small holes or channels built into the bridge's deck and parapets, to ensure water didn't collect and pool. These drainage systems may seem minor, but over centuries, they played a massive role in preventing structural decay. Wind, too, was taken into account. While stone bridges were heavy enough to resist most gusts, tall features like towers or gatehouses, common on medieval bridges, could be vulnerable. Builders used aerodynamic shaping and buttresses to stabilize these structures, often anchoring them into the piers themselves for added strength. The shape and orientation of the bridge often took prevailing wind direction into account, especially on open plains or coastal regions where storms were frequent. Then there were defensive concerns, elements that served both military and structural purposes. Many medieval bridges included fortified towers, gates, or drawbridges, especially those located at city entrances or crossing strategic waterways. These features were designed not just to repel invaders, but also to control movement and collect tolls. Some towers were built directly onto bridge piers, adding massive vertical weight. To support this, builders widened the base of the piers, reinforcing them with additional stonework and sometimes even hollow chambers inside to reduce weight without sacrificing bulk. The very materials of the bridge were also chosen with environmental pressures in mind. Builders preferred dense, hard stone for areas in direct contact with water. The stones were not all uniform. Different types were used in different areas of the bridge depending on their exposure to stress, water, or wear. For example, a more weather-resistant stone might be used on parapets and upper surfaces, while a softer, more workable stone could be used in protected areas to speed up construction. These environmental considerations were not afterthoughts. They were embedded in every stage of the design and construction. Medieval builders didn't separate structure from nature. They saw them as part of the same equation. Every crack in a riverbed, every shift in wind, every swell of floodwater was studied, respected, and woven into the design. And the proof of their success? These bridges remain. They've weathered centuries of storms, floods, earthquakes, and war. They've endured far longer than many of the governments, kingdoms, and civilizations that commissioned them. They still stand, not because they resisted nature, but because they flowed with it, silent, unshaken witnesses to the power of ancient ingenuity. In an age defined by rapid development, disposable materials, and projects built for profit over permanence, the quiet endurance of medieval bridges offers a powerful and humbling contrast. These structures were not built in haste, nor were they constructed with the intention of cutting costs or maximizing short-term efficiency. They were made to last, not for years or decades, but for generations, even centuries. And now, standing as proud relics of the past, they offer more than a glimpse into history. They offer lessons. Lessons not just in engineering, but in patience, purpose, and the deep connection between human labor and the natural world. One of the most obvious lessons is the value of time. Modern infrastructure is often built with tight deadlines and expectations of speed, leading to shortcuts and premature deterioration. In contrast, medieval builders understood that time was not an obstacle to overcome, but a tool to work with. A single bridge could take decades to complete, sometimes even longer if war, famine, or weather interrupted construction. And yet, there was no panic, no rush to finish. The builders knew they were contributing to something larger than themselves, something that might not be finished in their lifetime, but would serve others long after they were gone. This long-term vision stands in stark contrast to the short-term mindset of much of today's construction. Planned obsolescence, budget constraints, and political timelines have led to infrastructure that begins to crumble within decades. Bridges collapse not from natural disasters alone, but from corrosion, poor planning, and inadequate maintenance. Meanwhile, stone bridges built centuries ago still span rivers across Europe and Asia, carrying pedestrians, cyclists, and even vehicles, with little more than occasional reinforcement. Another critical lesson lies in material consciousness. Medieval builders didn't have access to modern materials like steel, reinforced concrete, or synthetic composites. They relied on what nature provided: stone, timber, iron, and lime. And yet they crafted structures that have withstood every imaginable test. Rather than forcing materials into submission, they studied them, respected their strengths and weaknesses, and used them in ways that aligned with their natural properties. They didn't try to make stone behave like steel. They let stone do what stone does best: endure, resist compression, and age gracefully. This respect for materials extended into craftsmanship. In today's world of prefabricated parts and automated construction, the notion of carving each stone by hand seems almost alien. But that is precisely what gave medieval bridges their integrity. Each block was shaped with attention, laid with care, and aligned with precision. There was no tolerance for error because the structure relied on the unity of every individual piece. The result was a kind of structural poetry, beauty and strength inseparably intertwined. The builders also had a holistic understanding of design, one that blended function with aesthetics and meaning. Bridges were not just tools to get from one side to the other, they were symbolic crossings between regions, between classes, even between the earthly and the divine. Many were adorned with statues, chapels, or inscriptions. They stood as landmarks and statements of power, piety, or communal unity. The experience of crossing such a bridge was not just physical, it was emotional and spiritual. Today, as we move through utilitarian concrete spans with little character, that sense of reverence is largely lost. But medieval bridges remind us that even infrastructure can elevate the human experience. Perhaps the most powerful lesson of all is humility. Medieval builders worked without computer simulations, without electric tools, without the luxury of modern machinery. And yet their work outlasts ours. Why? Because they were humble enough to listen. They listened to the river's current, to the stone's grain, to the lessons of nature and the wisdom passed down from earlier generations. They didn't impose their will on the world. They collaborated with it, and that collaboration made all the difference. Their approach was rooted in continuity. A bridge was not just a project, it was a gift to the future. It was a way to honor the past, serve the present, and shape the generations to come. Today, we are often so focused on innovation that we forget the power of tradition. But there is no shame in learning from those who came before us, especially when their work still stands firm after hundreds of years. Moreover, these bridges remind us of the dignity of labor. Every block of stone placed by hand, every beam hewn from forest trees, every calculation done in the mind rather than on a screen, speaks to the sacred nature of human effort. These builders poured themselves into their work, not for fame, not for speed, but for the sheer pride of doing something well, something that mattered. They built not just with skill, but with soul. And now, centuries later, their work still speaks. It speaks to us from quiet valleys and bustling town centers. It whispers across flowing rivers and echoes beneath arches worn smooth by time. It reminds us that true strength is not just about resisting collapse, but about harmonizing with the world around us. That longevity is not a fluke, but the result of intention, care, and vision. As we face the challenges of climate change, crumbling infrastructure, and a disposable culture, the medieval bridge stands not just as a monument, but as a model of how to build wisely, live patiently, and create not just for now, but forever.